Welcome, Wildcats, to your very last note-taking session of the school year. I am, of course, talking about section 10.5, solving logarithmic equations. Now, solving logarithmic equations is going to be very similar to solving exponential equations. They are, in fact, opposites of each other. So just like last time, I really want you to follow along with what I'm saying and not just write down what's on the slides, but actually follow the steps as I'm verbally explaining what's happening. A lot of these steps, you'll have them written down, you'll see A, you'll see B, but you won't understand how to get from A to B without actually listening to what's happening there. So with that, one real quick reminder. Common logarithm is a logarithm with a base of 10, or one that doesn't have a base written at all, like log of n. A natural log is a logarithm with base e, but we don't write log base e, we write natural log, ln. Guys, that is a lowercase l, not an I. I was getting that question a lot for 10.4. Lowercase l, not an I. So with that, let's move on to what the problems actually look like. Now, problems 1 through 6 in 10.5 are not quite as easy as they were in 10.4. Because this time they're not actually going to give you the graph. That means we have to create the graph. Well, to create the graph, that we've done before. We do it in Desmos all the time. So, I know it's kind of sad, but all you have to do is graph the left side of the equation. Don't forget though, if there's no x in one of the two sides, you just have to put an equals y for that. So if you have something like 16 equals log base 6 of x, well, all you need to do is, on the side that says 16, put 16 equals y when you graph it. Don't just put 16 or you won't get anything. Next, you're going to graph the right side of the equation with that same addendum. If there's no x, put the equals y. Finally, you're going to have to find where those two graphs cross. Now, a lot of these problems, they're logarithmic. So because of that, they're going to cross in really awkward locations. This is going to mean having to play with your window quite a bit. For example, there's one question that if you just try to scroll until they cross, you would scroll for hours without finding where they cross. They do eventually cross, and if you just try to zoom out until you see them cross, you're going to get what looks like two horizontal lines. So you won't be able to see where they oh, excuse me. You won't be able to see where they cross that way either. So, in cases like that, figure out what would be a reasonable y to set. So like 0 to 50, 0 to 10, whatever's reasonable for that problem. Then, just keep making your x value bigger and bigger and bigger and bigger and bigger until you find where they cross. Once they've crossed, you're done. It's really as easy as that. But it does mean having to play with your window in Desmos using that wrench icon in the top right of the screen. Once you've figured out where they cross, you're going to type into HRW the x value of the intersection. It's in whatever form the question wants. So if it says an exponential form, then you'd end up with something like 10 to the 15th power. If they want rounded to the nearest 3 decimal places, you'd have something like 15.023, etc. Just take a look at what form they want and what answer you've got. Now, if they say in simplest form, that oftentimes is going to mean the answer is a fraction and they will not accept the decimal approximation. So pay attention to that. Questions 7 through 10. In general, logarithmic problems are exactly as easy to solve as exponential problems, algebraically. Unfortunately, HRW has chosen a couple of esoteric examples, a couple of really weird examples. To give you an example of one of the weird ones they picked, They wrote this. And 9 out of 10 students that I have had have taken one look at this question and they've immediately shut off their Chromebook, closed it, and they said they would take whatever grade they got. Guys, this problem is not as hard as it looks if you take it piece by piece, constantly simplifying it, instead of looking at the problem as a whole and going, I have no idea where to start. Because I know that's what most of you are thinking when you see this. You have no idea where to start. Well, let's look at PEMDAS backwards. Addition, subtraction. Is there any? Yes. But all of the addition and subtraction is on the inside of parentheses. So we can't do it yet. Let's go to multiplication and division. On the left side of the equal sign, there isn't any. But on the right side of the equal sign, that negative sign out front, that means times -1. So we can distribute that negative sign to simplify our problem a little bit. And when we do that, remember log base 6 of x minus 1 over 4? That's just a number. So that's the first number that gets our negative. And then that plus 2 tacked onto the end, that's a second number. That also gets our negative. So we end up with negative log base 6 of x minus 1 over 4. Notice that the negative sign did not go within that second set of parentheses. That's because log base 6 of x minus 1 over 4 is a single number. So that as a whole gets the negative sign. It doesn't get distributed into the inside of that. And then our plus 2 just became -2. So we just flipped the sign. Okay, now we've gotten rid of one set of our parentheses. So let's go back to PEMDAS backwards. Is there any addition or subtraction? Well, yeah, I'm subtracting log base 6 of x minus 1 over 4, and I'm also subtracting 2. The question we ask ourselves is, which one do we do the opposite of? Remember though, we're trying to get all of the x's on one side of the equation. So in this case, we're going to take that log on the right, log base 6 of x minus 1 over 4, and we're going to add it to both sides. That's going to just move it over to the left as addition instead of subtraction and just completely get rid of it on the right. We're done with it on the right. Okay. Now is there any addition or subtraction? There is, and it's between two logarithms. And if you remember back to when we were talking about the properties of logarithms, we have a special rule when there's addition between two logarithms if they have the same base. Just so happens that both of these are log base 6. Well, that means we can apply our special rule. That rule was the product property. Product property says if they have the same base and there's addition between them, we can multiply what we're taking the log of together. In this case, that would be x times x minus 1 over 4. Well, we can distribute that x through the parentheses. So x times x is x squared, and x times 1/4 is x over 4. So we get log base 6 of x squared minus x over 4. And that's still going to equal that 2 on the other side. Now look at what we've got though. We have the only addition and subtraction left is on the inside of parentheses. There's no multiplication or division, so that takes us to our exponents. And you may be thinking that the only exponent is on the inside, that x squared, and you'd be right. But remember that a logarithm is just the inverse of an exponent. So we're actually going to use that and realize that this is the point where we can get rid of our logarithm. How are we going to do that? We're going to use another property of logarithms that we've learned. The fact that the inverse of log base 6 is 6 raised to a power. So we're going to take each side, the left and the right, and we're going to raise it. We're going to make those sides the power and 6 the base. So make each side an exponent with a base of 6. Now when we do that on the left, 6 raised to the log base 6 of x squared. All that does is it leaves what's inside the logarithm. So x squared minus x over 4. Now, what's on the right, 1 over 36, might surprise you. because a negative 2 became a positive number. But the reason for that is simple. Remember that we're taking 6 raised to the negative second power. Well, that's the same as saying 1 over 6 squared. That negative in the exponent just flips it to the bottom of the fraction. So 1 over 36, because 6 squared is 36. The next step is obvious to me because I don't like fractions. I just get rid of fractions wherever, whenever, and however I can. In this case, that's by multiplying by the least common denominator, or 36. So if I multiply both sides by 36, then I get 36x squared, and then 36 times x over 4 is 9, so minus 9x, and then 1 over 36 times 36 is just 1. Now, this is starting to look a lot like a quadratic equation, which is good because we already learned how to solve those. By subtracting 1 from both sides, we get a quadratic equation, ax squared plus bx plus c equals 0. That's what we were looking for. By getting to this point, we're now able to use any of our methods of solving quadratics that we've learned. I personally like to factor this one. The factors of 36 that add together to give me 9, well, negative 9 specifically, when 1 is positive and 1 is negative. Those factors are 12 and 3. So 12x plus 1, 3x minus 1. Those are our factors, and if you FOIL that out, you'll see that it equals what we had above. Now that we factored it, we can solve. So 12x plus 1, set that equal to 0. 3x minus 1, set that equal to 0. 3x minus 1 equals 0 means that 3x equals 1. And then if you divide that by 3, you get x equals 1 over 3. Same thing with your 12x plus 1. If that equals 0, then 12x equals negative 1. Divide by 12, that gives you x equals negative 1 over 12. Now, we do have a small problem with this. The small problem is that we know what x is. It's either 1/3 or negative 1 over 12. You're going to see on your answers for these problems that they're going to ask you for which one's the answer and which one's extraneous. There is no easy way that you guys have to tell which one's which. However, if you graph each of these separate steps, you're going to see that same thing that I taught you before with the vertical line on Desmos. As you graph each one, you'll get a vertical line. So if you graph log base 6 of x equals negative all that we started with, you'll get a vertical line. There will be a couple points, a couple of these steps, where it's not only going to have the same vertical line that you started with, but it's also going to have a second line. It'll have 2 vertical lines. So that vertical line that's there in some but not all of them, that's your extraneous solution. So in this case, if you do that multiple times, you're going to see that every single one of these steps has a vertical line at 1 over 3, or 1/3. But only a couple of them have that shadow line, that second one at negative 1 over 12. That tells you that your answer is 1 over 3, and your extraneous solution is negative 1 over 12. HRW wants you to put it in exactly like that. So, unfortunately, if you try to put the equation here, 36x squared minus 9x minus 1 into Desmos and get your solution that way, just by seeing where it crosses the x-axis, which is one way that I taught you how to do it, it's going to give you 0.33333 and negative, I think that's 0.08333. And unless you happen to know how those convert to fractions off the top of your head, you might be in for a rough time on that. I recommend trying to factor first if you can. If you can't factor it, then feel free to take a shot of graphing it trying to figure out where those decimals are and what they are as fractions, because it does want the answer as a fraction. So, guys, that is not only your very last set of notes for this Algebra 2 school year, it is also the introduction to your very last HRW assignment for the school year. So let's finish this one off strong. Let's work as best as we can on it. Problems 7 through 10 will give you problems here and there, but please ask if you need help. That is what I am here for. We'll be getting our review at the start of next week, or the review at the end of this week, the test at the start of next week, and then guys, it's right into our last two things. Unit 11 is just 2 separate projects to finish out the school year before our final. You got this, Wildcats. Good luck.